All right, folks, welcome to this month's Ask Mayfield Anything. I really appreciate you taking the time joining us today. And we are going to be spending some time talking about 2026 National Electrical Code today. And the new cycle just has been released. If you are interested in looking at the actual language, one, you can actually, the hard copies are being mailed now. So if you order a hard copy, you can get that. And also at the NFPA link site, you can go to that and you can see that all that language as well. So if you want to follow along, highly encourage you to do that. If you want to have access to it, that's really how you're going to be able to see everything. So going to go through, and specifically we're going to keep a focus on energy storage systems. So looking at Article 706 and some of the adjacent articles or articles that are applicable with 706, and that's going to be the biggest thing that we're really focusing in on today. And just so you know, there's the Q&A feature of the webinar here. So if you have questions, we definitely want to hear those questions and see what you have or hear from you in terms of what you're looking for. As we're going along, put those questions in there. I will do my best to get to those questions and incorporate them into the conversation. We will, if it's a topic that we're going to come up with, I'll probably hold it or anything like that. But by all means, this is what we're looking for. We want to have that interaction and be able to work with you all as much as we possibly can. So with that, let's get going. And a quick introduction for those of you who may not know Mayfield Renewables. We are a consulting engineering firm. We do project engineering, we do education and training, things like this. We're on actually just the heels of our education summit that we just hosted up in Seattle last week. And our guest, Jason Fisher, was there with us as well and talking about some of the topics that we're going to cover here today. So we are involved in the solar and storage industry. Again, we're doing a lot of project engineering, so we work on the projects going in, and would love to talk to you all if there's any types of projects that you want to need help on that we can support, any consulting or even education and training, which we do a lot of specific for teams, and have our individual courses on our website. So my name is Ryan Mayfield, founder of Mayfield Renewables, and started the company in 2007. I've been very active in the industry as a whole. And then most recently, I was on the Codemaking Panel 13. I was, for the first cycle in the 2026 cycle, I was on the Codemaking Panel, sat in there with Jason as well. And so quite an interesting experience, and looking forward to the 2029 cycle. But this is kind of a culmination of things that we learned there, and so trying to help give some of the insight on the hows and the whys for what we see in 2026. We have Jason Fisher, founder of Solar Tech Consulting, with us as well. Jason has been highly involved in codes and standards in general, and probably too many to list. But Jason, thanks for joining us, and it was great to see you in Seattle. But will you do a quick introduction for our audience, just to kind of tell them who you are and what you're doing?
Sure. Yeah. Thanks, Ryan. And thanks for having me. Jason Fisher, I've been in the renewables industry since the mid 1990s or so. Got started with small PV and battery systems, lots of that sort of stuff back then, and have been in and out of a lot of different places, a lot of different firms across the industry over these years. And for the last 10 to 15 years, maybe now. Yeah, I've been spending a lot of time on codes and standards, been on the National Electrical Code for 4 cycles, represent SIA and CMP4, and also represent SEI on CMP 13. And I'm on a number of UL technical committees and a bunch of miscellaneous stuff. So thanks for having me, and happy to talk about 2026.
Awesome. Yes. Fun stuff. I know. I've been running around the house holding my 2026 code and showing it to anybody who will listen to me, which is few people in my house anymore, about code and how exciting and thrilling it all is. Real quick note for those of you on the call. So CMP, code making panel, and as it relates to our industry, the biggest one is Article 690. And then on CMP 13, which is the one Jason and I both sit on, that's 706 is probably the most notable for this conversation, at least. There are other articles that are under our purview, but I would say that those are the, just so you know, kind of what that relationship is and where to go, and who to start blaming and giving credit to on when you see things that you do and don't like in those different articles. All right. So key updates for energy storage systems is what we're going to get into today. Real quick, a couple just housekeeping things more than anything, or just kind of baseline piece of information. This is straight from the NFPA site. It was, as of yesterday, I think even. And really the big point here is code is put into effect, is adopted generally at the state level. You'll see that there are some locations where they do it at the county or municipality level. So depending on where you live, that could be the case. By and large, it's at the state level, and it's at whatever timeline the states work under. So I would say most notable, Massachusetts, they adopt the current code when it's released or when it's officially, that's that year. So Massachusetts, January 1, 2026 will be under the 2026 code. I don't know of any other locations. Jason, we were talking earlier. I don't think that there's any others that really stand out. There might be, but nothing that's like super, especially in the PV and battery world. But we do have a number. But we do have a number that come in later in the year. Go ahead.
That's right. I was just going to say, like, by late summer, a bunch more will have popped up, and then by the fall, yeah, we probably have about maybe 6 to 8 different states, including some bigger ones.
Yeah, and so I think the message here for the audience is check in with your jurisdiction, understand what that adoption timeline looks like, and even so, I'll just speak from where I sit in Oregon. It's typically October of that year. So October, so in about a year's time, we should see the 2026 be put into effect. But we're in the process now of doing amendments and making changes. So if you are, at whatever state level you're at, if there's things in the 2026 code that you want to address, and maybe at your own local level having an impact, now is the time to be getting involved with that. The other big one that I'll just note is California. Folks probably know California is a full code cycle behind. It's because of the way building codes and electrical code don't completely match up in terms of their timeline. So January 1, 2026, California will be officially on 2023. So if you're in California, just be aware of that. That's how that kind of cycle works. All right, just super quick on this one, just kind of how we lay our slides out. You're going to see a lot of text in these. Typically in our AMAs, we try and avoid text heavy, but obviously with code, when you're trying to talk about code language, you kind of have to see that language in order to really understand it. So we have a lot of code language in here. We put it in italics so that you see, when it's actual code language, when we're doing it verbatim and not paraphrasing. So that's how you'll see the text come on. The highlights are there to indicate changes from 23 to 26 in this case. All the language you'll see is in 2026. So if it's highlighted, it just means there was a change from the previous cycle, not that it's more important for some other reason. And then new code language is always preceded with an N with highlighted as well. So there's a couple instances of that we're going to talk about in our discussion here today. All right. Now that that's out of the way, let's actually talk about code. It's fun stuff. So 480 and 706. This is a topic, and I know, Jason, you wanted to talk about this, and so I'll kind of set the stage and you can kind of help round it up. So Article 480 is batteries, if you stationary battery systems, and you see there the scope. We put the scope of both of these articles in there to kind of help give that sense. So greater than 1 kilowatt hour, that's where installation of batteries are going to apply. And there's, I think, some confusion and some like, what does that mean? What is a battery? We have batteries typically in our energy storage system. So am I supposed to go look at 480? Am I supposed to look at 706? And the big thing there is, if you see that informational note under 480, it talks about listed energy storage systems. Listed systems are going to be those that have gone through the 9540 process and been listed. So that would be a system. It could be a DC system. It could be an AC system, but it's a system that's been evaluated. Batteries by themselves are typically looked at under UL 1973, and that's the big differentiator. Jason, what would you like? How would you add on to that?
Yeah, I mean, I think what's relevant for those who have been playing along through the last few editions of the NEC, with 706 introduced in 2017, right? And then ever since then, it's just been this process of trying to understand, well, we had this existing article, which has been in there forever, 480 batteries. It's like, but if my energy storage system is battery based, which one do I use? I think that it's finally resolved, but it was definitely, even last cycle, there were attempts at trying to make this a little bit clearer of when you'd use one article over another.
Mhm.
And ironically, the way that the code making panel, as you recall, Ryan, sort of resolved this was just to say, well, it's not up to the National Electrical Code to say when you install a battery system or when you install an energy storage system. The point for the National Electrical Code is, because it's an installation code and it's a safety code, it is, okay, if you are installing one of these, this is how you do it safely. And so there's a couple of things which maybe you don't see because they're deletions that are relevant to this discussion, which is that in both 480 and 706, and in the definitions of energy storage system and the previous definition of stationary standby battery, there was language around like usage, like a battery which spends most of its time at float voltage or something like this, I think is what used to say for the stationary battery. And the energy storage sort of like, oh, it's interconnected with wire, with the premises wiring, and it can be interactive or whatever. It's like there was this sort of attempt to say, oh, well, the use of these two pieces of equipment defines when you can install one or the other per the National Electrical Code. And that just didn't make sense to a lot of people, including myself, because, I mean, for instance, the National Electrical Code does not tell you when you install a fire alarm system. It tells you how to install a fire alarm system. And there's other codes that influence this. And as we all know, these codes get adopted and modified and interpreted differently throughout the US. So fortunately, everybody in the committee kind of said, you know what, that made sense. Let's just go that way. And so you should see a lot of this language, which I think tossed people into little briar patches here and there over the years. Maybe that just goes away, and then maybe it just comes back to what I think it kind of used to be, which is, does my jurisdiction, is my application, whatever it is, will allow me to install this, separate battery system with separate inverter, and using these chemistries and all that, using 480, then go for it. This is how it's installed. And
Mhm.
that's, I think, the big difference here. And hopefully we've turned a corner there. There are two important things I must point out, which is that both these articles still have a 1 kilowatt hour limit, so they don't have to be enforced to any technologies below 1 kilowatt hour. The obvious question somebody's probably thinking about putting into the Q&A is, well, what happens below 1 kilowatt hour? This is where it's like, well, you better do something that makes sense for you and everybody else in the world. But the NEC doesn't exactly, explicitly sort of state that. And then the other
Yeah.
final thing I'd say is that 706, even though that's all we're usually talking about, is that it's a battery energy storage system. Just want to point out that it is very, very much sort of source agnostic as far as what the actual energy source, storage source is.
Yeah, I haven't, we don't have it on the screen, and I won't say this because I don't remember in the 2026, but I know in 23 there's there's an informational note. Hey, there's all these different types of storage systems. They talk about capacitors and different ways
Yeah.
of having energy storage. It doesn't have to be a battery base or electrochemical. Great question that came in was, how does NEC play with NFPA 855? And when you go through and read Article 706 in the informational notes, you will see references to 855. The one that I can immediately think of is in the commissioning and maintenance section. There's a reference to 855.
Yeah.
And first off, informational notes are not enforceable parts of code. And so that's one thing for people to be aware of. They're exactly what they're called. They're informational, and it's good information, but you can't have an inspector or authority can't say, oh, this note said go look at 855 for this. You have to do it per 855. I would say it's a really good idea because 855 is probably your best source of information on how to do it. Kind of what you were just saying, Jason. If it's less than a kilowatt hour, if it's kind of outside that realm, how should I do it? If you're using things like this 855 standard, you're going to be, best off. So how do they play? I guess there is references, but there's not a direct line of you have to use 855 because of anything that NEC specifically says.
Yeah, I think the one thing that where there is an actual connection, it's a little esoteric in how it's done, but the definition of energy storage system in
Mm-hmm.
2026 is now an extract from 855, which is
Oh,
just this sort of, procedural thing that NFPA does where what that really means is now the definition that is published in NFPA 70 and 855 will always be lockstep with each other.
got it.
So I don't think that was a huge thing, but again, it's more of that trying to move forward with something where everybody can gain a lot more confidence that we're all on the same page.
Yep. Great. And then there's this other question about appliances and batteries that are installed in those. And so I think there's a lot of discussion going on around appliance listings and things like that, but that would not be an energy storage system. That's not something that's getting installed. I mean, it's part of a listed component. So
Yeah.
that
I
would
mean,
be just something.
right now we just have the language in the code to work from, and
Okay.
there's no such thing in the code. A lot of these terms that are being used to talk about, different types of applying these technologies are not used in the code. So I'll just warn you that, you probably get put into one of the buckets that's, exists currently in the code today.
Yep, exactly. All right, let's move on just so we make sure there's some other topics I know that we want to spend some time on talking about. And so jumping into 706 specifically, we're showing the language around disconnecting means, and we're only showing you there's other subsections here. The kind of, as we were doing the prep, we were like, what are we trying to drive at here? How are we trying to address disconnecting means? And there's definitely some things to say here, but wanting to point, hey, this is the starting point. This is the the starting point of what you need, where you need to go look, and what you need to be looking at in terms of the disconnecting means. One of the things, Jason, that you mentioned in our prep was this kind of coalescing or matching up of 706 disconnecting means, making it look and feel a lot more like 690, just kind of the equipment disconnecting means and how we're going to do it. And so that's been an ongoing thing. I think one of the things that from 2020 to 23, we saw some relatively big changes that happened, and it was the same kind of thing. So I think that we are trying to match 706, which is in the grand scheme, is a very, very young article. 2017 was the very first time we saw it, and trying to match that up with the rest of code. So making sure that we are being consistent throughout code in terms of what are we requiring, how are we requiring it, and how those fit together.
Yeah. Yeah. I mean, I think the general theme for the 2026 cycle for a lot of the articles that are important to us in renewables is that we are trying to standardize as much as possible, simplify as much as possible, align. And this was very much supported by NFPA staff and the Corralling Committee, in keeping with the goals of the NEC, which is to try to, reduce as much as possible any areas that might be looked at as conflicting or contradicting or anything like that. And so that's one of the reasons we're getting some traction behind this idea of shouldn't we have we have service disconnecting means requirements for service disconnects, and they're not going to get into the nitty gritty of what's exactly connected to that service, right? They all sort of the same things. Shouldn't we have a similar thing going on for power sources? where the system disconnect for the power source, the actual disconnect that disconnects the power source, whatever it is, from everything else, has standard requirements. And that just makes sense. Unfortunately, we're just starting, we've done a lot of that, and we're not quite there, but 705.20 is intended to continue to be the place you go to look for those sort of answers. And so you'll see a lot of stuff that's either now just pointers or maybe deleted, or very simple statements um, that are sort of getting us down that path. And this is one of them.
So yeah, so I think kind of, yeah, getting all of the code sections to look similar. And I think this is something that and one of the things I know was mentioned as we went through the whole process, not trying to duplicate code sections, or be repeating anything, or even trying to somewhat eliminate directing people within code. If there's a requirement that's already there, people should be using those requirements and not have to be kind of told really separately how to get there or how to use those.
Yeah. But maybe I see a question about switches that are part of a BESS. Yeah, I mean, maybe that's something we should point out, right? And we have a line, I think.
Look at that diagram.
Yeah. Yeah. I mean, very simple diagram, but yeah, that one right there is the system disconnect, right? So that's all that 706.15 is talking about. And it looks like the PV system disconnect above it, and that's the whole idea, right? Is that they're basically the same requirements. But yeah, this question of like, well, what happens on the energy storage system side? This is again another really important thread that hopefully you'll see that be noticeable throughout 706. And again, a lot of the language has been deleted, so it's not going to necessarily look like something major was changed there, but a lot of language was deleted that should be covered by the listing. And that's the long answer to that question, which is if you're talking about means of disconnection or isolation or anything inside of the listed energy storage system, then that all should be covered under the listing, which means it should be addressed in the installation instructions and in the information that's provided to you by the manufacturer, because that's your best way of proving that it's covered under the listing. But yeah, you should have some relief there, and it hopefully is that 706 is going to be less of a, I don't know, adding less confusion into those discussions, I guess.
Sure. And in 706.15, and again, I know we didn't show all the language, but there are multiple options to meet the requirements for that energy storage system disconnect, one of which is integrated into the BESS. And so if you have your energy storage system is listed 9540, and we're not showing it in this image, we're showing something external, but you can have a integrated disconnect that would meet the code requirement, because you have that disconnect, and in that situation, it would be on the DC side. And so what we are showing here is, this DC coupled system where the PV and the energy storage are getting coupled together on the DC side. How that exactly happens through the equipment is going to vary based on the manufacturers, how exactly that is. But I think one of the things that this other question that came up was talking about AHJs being confused by DC coupled systems, but they're, where the components are certified together, but they're individual parts. And so I think that's part of it. Actually goes into the next question, asking about if you have a ESS with an inverter that's listed together, is it the inverter's output circuit that is the ESS disconnecting needs? And so when you look at that ESS, the output of that would be that is the energy storage system. If you have a battery, call it one box, call it two boxes, whatever it is. But if it's a listed item, if they're listed together, then the output is AC in that situation, and that would be the disconnecting means.
Yeah. Yeah, I think these are great questions that illustrate, what you all don't see and hear are all of the debates and discussions and all that go on, during the code making process, and in all the working groups, and even beforehand, trying to figure out, from those of us, that would be actively submitting inputs and everything. I can just say that in general, one thing that, at least that I feel, and I think other folks like myself have used this document for, decades now. We all kind of got to the point where it's like, it's sometimes more isn't better and sometimes less is more. And so you might find that, oh, it doesn't specifically address this exact situation, but take another look at it again and again and read through it again. It's like, does it actually say I can't do this? And, does it support this, this approach in general because I'm meeting these requirements? Because like that's the answer to something like, does the inverter circuit breaker qualify? The first the first thing that you'd have to do is, does it meet the requirements of 706.15, and the related 705.20? That's the first place to start, because if it doesn't, then you got your answer there. It doesn't matter where it's located or what it's connected to or anything. And then from there, it's like, okay, well, wait, but is this inverter part of this energy storage system or is it separate? That's where, again, you go back to, well, what does 706 say? It's for a listed energy storage system that may or may not include an inverter. So if you provide documentation, that's like, no, this is all covered under this one listing, then that should give you everything you need to, drive home that argument, which is like everything downstream or, from that point forward is all part of the ESS and is all part of the listing. But again, I'll just stress, this is where you need to lean on manufacturers to make sure that they've given you the documents that you need to help support these discussions.
Yeah, and I think there's a handful of questions. I think they're all interrelated, so I'm going to try and address kind of them all in one. So I think we already talked about a couple of these, but in this situation, we're showing a DC coupled system. So we could call that energy storage in the bottom left corner. That is your UL 9540 energy storage system, and that would include the batteries and probably the BMS and things like that. And we have our energy storage disconnect on the output of that. We're pairing it with a multi-mode inverter. So that's kind of it's a completely legitimate way of doing it. And that would be, what we're going to call that energy storage disconnect, versus if it was a complete system with the inverter, the output would be that energy storage system disconnect, because that's how it was listed, as an energy storage system with that AC output. And then the last one, Daniel asked a great question, or little clarification. So with what we're saying, should the energy storage disconnect and the PV system disconnect be inside the multi-mode inverter? And the answer is it could be, and that would meet code requirement, but it does not have to be. So if it is not included, if it's not integrated into the inverter or into whatever that equipment is that you're building, then you would have to add so we're showing an external one. So there's 3 items in there, excuse me, in 706.15, there's 3 ways that you can meet the disconnecting means for the system: integrated, external, and then a situation where you can lock the disconnect depending on its location.
Yeah, and one thing that is not covered anywhere in 706 or 705 or anything is a external lockable visible blade, whatever the utility might require in your area. It's again, that's just not addressed in the NEC. It never has been. If you have to install one, then you should follow the general rules in the NEC to install it. But there is no guidance on what would satisfy those applications. I think you might have to have a similar one for
right.
other
So, that's what I was going to say, is there's a very good chance that you would have to have one that in the exact same location or serving a code purpose, not a utility purpose. And you can utilize one disconnect to serve multiple means. If nothing's saying that just because the utility wants to see one, it has to be separate. So you could commingle those, I guess, not co-locate, but have an individual disconnect serving multiple means. Great. I think we got this one pretty well. Not sure if there's anything else on disconnecting means that you really wanted to cover, Jason. I know there's questions, but let's keep going.
Keep going, yeah.
We have some good stuff here to talk about, so we'll probably spend a few minutes on this one. So this was really what Jason came to Seattle for our summit and spent whole hour plus talking about UL 3141, power control systems, energy management systems. And so there's a relatively big change in 2026. And that the number one big change is energy management systems, which were in Article 750. They've been in 750 for a long, long time. The whole article got picked up and moved into 130. So for the code users out there that are familiar with it, the 700s, the Chapter 7 articles were special installations, special considerations, and anything in chapters 1 through 4 are general requirements. And so it's a pretty big deal to take it from a special situation to, in my opinion, to a general requirement. So we are now in Article 130. So if you are looking around and you see this reference to 130, had never heard of that before, it's because it didn't exist before, and we now have this language here. We're showing UL 3141 on here as well, a UL standard that's being finalized right now. The questions are going to come up from somebody, at least somebody's already asking the question in their head of when will we see 3141, and anywhere from end of the year to sometime next year is the answer I've gotten. I don't know if you have any better answer than that, Jason.
Yeah, I mean, it's so yeah, it's something I've been involved in from the start. I have a pretty good handle on it. I'll just point out that what's with regard to the schedule of when is it going to be published, it's actually published. It's just that it's published as an outline. It's actually the second issue of the outline, and people are listing products to it. So don't be like shocked or say, wait, Ryan said it wasn't going to come out or whatever, because you can list products to an outline. This is an outline investigation is just something UL creates to sort of at the start of a brand new standard. And then it's going to go to the full technical committee, which is already formed and is already working in work groups and all this, into that sort of first edition that's going to be balloted and go through the full ANSI development process. And that's where, yeah, I mean, I know that the goal is still to try to get to ballot before the end of the year. It will take some time. I think that, let's say realistic is, sometime in the spring is when you might just be able to buy a full version of it. And there will be some major changes between the issue 2 that's currently available and that, but there's a lot that's going to be the same. And in no way whatsoever is a product that's been evaluated and listed to the current, to the outline of investigation. In no way is that not listed. It is listed.
Okay.
It's just not the same.
Well, that's a good point. Maybe a little misunderstanding on my part. So you can list the outline of investigation. I would take it as that's a little bit of a risk on the manufacturer's part,
Yeah.
because if in balloting something says you have to turn it left instead of turn it right, and the manufacturer listed it to something that got changed, then they would have to go through the listing process again because something
Yeah,
significant
I mean,
changed.
there's nuance there, which is like they don't have to do anything if they don't make a change to the product. But to your point, Ryan, it's like maybe I've done something, I've built my product to the outline, to the requirements of the outline, and then I want to update it, middle of next year to add some other feature to the product. And now it's like, oh no, I have to go to the full ANSI standard and they address this thing differently than I built my system to. So that's sort of the risk. It
Got
doesn't
it.
mean that like you remove product off the shelf or something, but you're just sort of
Oh, okay. Okay.
stuck in
Good to know.
time.
Okay.
Yeah.
So if we start seeing manufacturers say we're UL 31 listed, it's to this outline, they would have to say it's to this outline investigation. We would have to know what it was
Yeah.
to.
And it's very similar to, UL's updating. I mean, everybody's updating standards all the time, but UL has so many that apply to us. And it's just that those are updates to an existing, edition.
Right.
So it's, you should think about it the same way. And yeah, the NEC doesn't actually distinguish and say must be an ANSI thing or something like this. You just must use a nationally recognized testing lab. And have a standard that everybody is comfortable with and that feels is appropriate for the language that's required. And so that's where, yeah, I definitely wouldn't be what I think, and sorry, because I've kind of warned you, if you pull my string on this topic, I'll go on for quite a while. But
We've
the
got a couple minutes.
okay, good. The I think the real take home is just saying that I have 3141 listing or a 3141 evaluation isn't good enough. It's not good enough today. It's not going to be good enough when it's published, because the PCS standard and this topic of energy management systems and PCS, which is sort of according to the NEC as a subset of energy management systems, um, that they can perform lots of different functions and have lots of different features to them. There's only one that the NEC really cares about, and that's the one that's here. The 130, what's said there in 130.2, it shall be listed as a PCS. That is when you use a PCS for overload control, which means I'm not using traditional load calculations or nameplate ratings of all of my inverters or anything like that to come up with my minimum ampacity and overcurrent protection and all that. I'm going to use this PCS to manage the continuous current flow on these conductors and all that, regardless of what's connected to it. And I'm going to size all my wires and stuff to that. That's overload control that we've had a ton of success with across the code. Very excited about all this. It's a major change. It's been actually in place since 2020 in 705.13. But so now we're technically in the third cycle, but this is the second cycle where it's been, sort of source or load agnostic. And but that's the only thing the NEC says about PCS. Otherwise, it's like, okay, you just install the PCS, use general wiring, requirements and follow the instructions. But you should just understand that you could list a PCS to do all kinds of other stuff, which isn't NEC. And so the big warning here is, don't assume that just because somebody says I have this PCS listing or evaluation, I can utilize these special allowances like 120.7 in the 2026 code. Don't assume that. They have to actually back that up to show that they've been tested and listed for that function, for this overload control function.
Right. So there's like you said, there's multiple functions that a PCS can do, zero exports, non-import. There's all these different use cases or modes, I guess, that they could be using. But code really cares about, are we overloading conductors? Are we overloading bus bars? And a good question that came in, as I'm using those words, is overload or overload controller defined in the NEC?
Yeah, and overload is in 100.
Okay.
And that's that should be easy to find, because now all definitions are in Article 100 and they're all in alphabetical order. And with NFPA link, you can search everything electronically. This is the direction that the NFPA is going,
Right.
which should be helpful for all of us.
It's helpful when you understand, like, how the phrase is. I always like to use readily accessible. You're not going to find it in R's. You're going to find it in A's because it's accessible, readily. But
Except they're making us now put the full term in parentheses so that just for the sole purpose
when you
for
search,
electronic.
when you search, yeah. When you search, you'll find it when you electronically search it. But if you have the hard copy and you're in the R's, you're not going to find it. Anyway, that's an aside. So let's talk about this a little bit more, the overload function. And so again, you talked, it's a pretty big change. Well, we had it, you mentioned already, in 705.13. So really, this is allowing us to have potentially more sources, more PV, more batteries, more power sources connected to a bus bar than we would have in the past. And it's because our PCS, and correct me anywhere where I get this wrong or I misstate this, we have a PCS that's monitoring and making sure that the output of our energy, whatever those sources of power are, whether it's solar, batteries, utility, we're not going to overload that bus bar. And so we have this way of controlling that and not having to use brute force in terms of, you can only put 32 amps on this residential bus bar, and that's how you're going to be in compliance. Now code saying is, sure, you can put 60 amps on, but we got to make sure that that bus bar is not overloaded.
Yeah. This is why it's so critical to make sure that you fully understand the abilities of a PCS or a product that claims it has PCS, and that's fully documented, because it does have a tremendous value, that like I say, I'm pretty excited about with regards to our electrical design stuff, where we will now be able to, design conductors, bus bars, et cetera, not just for sources, but for loads as well, to the actual controlled load, and not some sort of predicted, likely to happen or worst case or whatever, all these other stuff that's happened to us in the past. So yeah, for bus bar connections, I think that's going to be a big one. I think a big one, and I think one of the reasons we have it here for ESS is, ever since we started the AC couple, back when we got started, right, everything was DC couple. But once we started the AC couple PV and storage, the obvious question was like, wait, I have to call both of these a source and then add up both of these things. And but when my PV is producing, I'm not also going to be, I'm going to be charging the battery, and so blah blah blah. But the fact is that the NEC just said, no, those are two sources, and there actually wasn't something that was preventing the two of them from both exporting at the same time. So you had to add those two nameplates together. That's a perfect example of now where it's like, well, if you can add PCS, to one or both of them, or to the panel board that's making the interconnection or whatever, then you can actually enforce a limit that's a practical current limit, right? And not just have to take the two nameplates and say, what is the maximum continuous current output, and use those. And so that's a big one. The other one is that, and you're starting to see this, I mean, some companies were, ahead of the times because they were kind of, actively engaged, is that you can have, a single inverter. Gone are the days where you had one inverter that is the same size and shape and weight and all that, but has four different nameplates on it, to allow you to have four different connection options. Because now with you can have one inverter with PCS built into it, where the PCS now just controls the output of the inverter, and now can allow you to tune the maximum continuous output, to a rating that matches, your design requirements and your interconnection requirements, et cetera. And then, we just go from there all over the place. We could have like system level, like, large scale plant controllers could be, PCS, and that would enforce, maximum import and export. You can do all kinds of different stuff with it. So there's a lot of different ways that this PCS could overlap the topic of energy storage, particularly battery energy storage. And that's why I think we wanted to talk about it here.
Yeah, and so I think one of the big takeaways that I'm hearing from you is something you said earlier was, there's a lot of different functions, a lot of different modes that a PCS can operate, or help our systems operate. And so for code compliance and for the application of code, really the question folks should be asking is, about the overload control. That is one of the features of PCS. And so you may have all these others, which are nice whiz bangs, but if they can't do overload control as far as putting into those applications, not saying you can't successfully and effectively and properly integrate something code compliant, but if you're going to be trying to utilizing these specific features, I guess they have to have that overload function.
Yeah, and everybody should know that PCS is always permitted; it's not required. But yeah, there's some benefits when you implement it, right?
Yeah, and so I was
ahead.
just going to say something you said earlier that I think might have slipped under the radar, might have slipped through, is in National Electrical Code, a PCS is a subset of a EMS. So an energy management system, a PCS is basically a type of EMS, is really how that looks at. So when you look at Article 130, it's titled Energy Management Systems, and a power control system is part of that. It's just a different, it's controlling the power, not necessarily controlling the loads, and which is, I think, a more historic thing on the EMS. So there's the question here on the bus bars, and so the question is, do they require the ampacity ratings for the PCS, and because of these 80% ratings, and so I guess I would love to hear your take on that, Jason.
I mean, required. I think there's always going to be a point at which you have to have the ampacity of a bus bar known.
Mm-hmm.
I don't know what exactly, we're asking here with regards to like published where and all that. But I guess the way that I'd answer it is that, listed panel boards, you know, that's all I can think of right now is like the one that's relevant to us. I guess, I guess we could have other things like switchgear and stuff like that you maybe have to dig into a little bit more. But I think with any listed panel board, you'll be able to get a main bus bar rating off of it. Um,
Mhm.
and if they don't publish it, then you ask them, well, what the hell is it? Yeah, and then with switchgear, it's like all about this, Ryan. It might be a little bit more complex, but somebody's going to have to know what the ampacity
Right.
is, various bus bars here and there. But it's not going to be like a requirement for PCS. It's just that if you actually want to take advantage of using PCS for these applications, you'd need to know that. Yes.
Exactly. No, I think that's a great answer on how to do that. All right. I think we're doing perfect on our timing. We have one more topic that we wanted to get into. And so I'm going to kind of move us along in our discussion. First off, this is just kind of a precursor. So we're moving into 702 is what we're going to do. So 702, those of you who don't have things memorized, which by the way, with 2029 changes happening, if you haven't memorized code sections and articles and things, like don't bother. It's a waste of your brain space at this point. If you have, then sorry to say, in 3 years, they're all going to be different and it's going to be really hard for us all. Anyway, 702 is talking about backup power systems. So these backup power systems that are not required by code, they're not life safety, they're not legally required standby systems, they're optional standby systems is what they are. And we're going to talk about this change. I'm going to show you the language in the next slide. But if you want some more background, there's a really good article in Solar Builder. So earlier this year in February, Solar Builder published this article talking about these kind of this discrepancy, this how Article 706, we have this getting pointed to Article 710, but we have also some commentary on Article 702. It was kind of this like everything's in parallel, but it's not quite the same direction. It's not quite going the same thing. And what the gist of it is for the audience is how to size our energy storage systems, how we are backing up our whatever our backup loads are. How do we size that in terms of kilowatts? What is the requirement? Do we have to back up the entire thing? Do we have to have, if you're going on a 200 amp service, do I have to put 200 amps of inverter in there? If I'm backing up a load panel that has a smaller amount, how do I do that? And in the 2023 version of Article 706, there's a direct pointing to Article 710 on how to size that, but there is a conflicting, I would say, way in Article 702. So I don't know if you want to expand
I
on
mean,
that at all, or if it's like it's a little bit of a conundrum, is really what it comes down to.
well, it's a tough one because well, when I got started in PV and batteries, I was using the 93 code, and all we had was 702. 710 didn't come into play until 2017, and it was sort of an extract from language that was from 690. But even this language around single largest load, I think wasn't added until 2008 code, I believe. So one thing I just say is like, anytime anybody says we've always been able to, it's like, nope, that's not true. You haven't always been. And if you wanted to say if anything was always, you'd say, well, 702 has always been there, which isn't technically true, but maybe it probably goes
I
pretty
mean,
damn far
you
back there.
say you
Probably,
can go far back enough, and
yeah, like
basically nothing was there.
if we weren't born, yeah, then it's old enough. So I just say that, like, yes, there was this window of time, which I feel somewhat guilty over, of where the interpretation was, or at least the interpretation that many of us wanted, was that for these battery systems, for these multi-mode inverters, that we would use the single largest load, and we would call that operation a standalone operation. But it just, you don't win every battle. And the fact is that there was a lot of reason. Part of the part of the problem with making a whole bunch of noise about something is that a lot of people start paying attention to it, and then you might not, have the same allies that you had before. And the fact is that standalone really, technically, in most of the use cases throughout the NEC, didn't have its own article, but it was used to mean like there was no utility connection, there was no
Right.
service.
Right.
So that was hard to say, like, oh, because you're not making the service just magically disappear. And then
Right.
everybody just kept on saying, well, but we have this category called optional standby system. And then I'll tell you the last thing, which is, and then we can get into the specific language, which is that once I decided personally, thought through this, I realized like there's actually a disadvantage to the industry in us continuing to somehow say like, oh no, we're special, we're not a standby system and all that, is because there are these two really important articles as well, 700 and 701, and those do emergency and legally required. And if we imagine a future like I do, where microgrids powered by clean renewables start to replace these massive generator systems that constantly operate during storms, outages, and all this other stuff, then we need to be part of that same suite of articles, 700, 701, 702. We don't want to, there's no advantage to saying we're somehow different. So,
Sure.
so that was, we all, many of us became a lot more focused on, okay, what do we need to try to get a little bit of relief in 702? And
Sure.
thus,
So let's look at that and kind of look at the language that we have. So I'm not going to read this to you. If you're following along, this is the code language. This was a new section, and this was as far as being in the room when it happened, kind of thing. This was an interesting watching how code is written and how code is adopted in real time. This was an interesting thing. We are showing you 702.4A3. There is A1 and A2. Recommend you go look at those. And A1 talks about doing a non-automatic transfer. So you have a manual transfer switch in terms of how you're able to, what the requirements are. Number 2 talks about PCS, so we just spent that time talking about energy management systems and PCS, and being able to use controls to also make sure that you are properly supplying the loads. And I guess maybe I should step back. 1 and 2 are there, and as folks are looking at number 3, really, again, the idea for code that we have safe and reliable electrical systems. We're not going to put people in harm's way. We're not going to put them in a situation where we're trying to back up some loads and we're going to create an overload situation. We're going to create shock hazards, things like that. So it's always helpful to go back to like, what are we trying to accomplish with code, and just make it so that people don't touch electricity, as some people like to say. So this got added in the 2026 language. And first off, you'll see it's for 1 and 2 family dwellings only. But we have this ability to have these multi-mode inverters listed as a PCS for overload control. So just kind of, that's one of the reasons why we spent so much time talking about that on PCS earlier. So we have this listing. So you need to ask your manufacturer, great, you're listed at 3141. Is it for overload control? Then we are going to look at Article 130, and there's where we see that largest single utilization equipment connected to the system. And part of the process was getting people in the on the code making panel comfortable with, well, what happens if I have a 60 amp inverter and 200 amps of load tries to start on? What's going to happen? And so the idea here is you see that if the shutdown occurs, it has that overload control, that we're going to have this non-automatic reconnection to that supply. So basically making sure that we're not going to have something trying to kick on and off, on and off, on and off, potentially causing some sort of a fire situation, or some sort of a hazard. So again, 1 and 2 family dwellings only, got that PCS listing. So these are kind of those big things to be paying attention to as we're moving forward. And again, 1 and 2 apply. You don't have to use this. You can use, if you have a listed PCS that can, take out some of your loads, and so that the inverter system was only going to try and connect to loads that it can supply, then there's definitely an answer. There's an answer for you.
Yeah, I mean, it was a very pragmatic, I think, consensus sort of place that we landed, like you're describing, Ryan. And what it will do in practice is return back to essentially saying that as long as you have a multi-mode inverter that's listed 1741, and then you have a PCS evaluation for it, then you can kind of use the language sort of that was in 710 before.
Right.
But this is, I think, great because we've kind of come full circle on the PCS discussion, because this is an example. This language does not exist in the issue 2, the outline of investigation. This language is being drafted on right now by a working group of technical committee members, and is very much anticipated to be part of the first edition when that gets published. But yeah, there is no published language right now for you to evaluate to.
Got it. Perfect. Okay, good to know. So this is going to be, we need the manufacturers so that hence why we're probably seeing more weight on this listing and this. Well, excellent. I guess any more, I mean, this is a pretty big just change or anything on kind of on the background information, anything on that, Jason, that you would like to kind of impart onto the group?
I mean, on this one in particular, yeah, I think I just make it clear that this whole 702.4a section is, talking about how you're basically, the changes that were made over 702 over the last couple cycles were a clarification that it's about connection of load to these sources, right? And so there's a lot of wiggle room here that should make it a little bit more straightforward when you're starting to handle things like microgrids and stuff like this. Is that a lot of the language that was sort of written with this idea, which is like, I have to have a transfer switch and it all has to be thought of in this one way, all across from 700, 701, and 702. There's been a lot of work to kind of, again, try to simplify, try to reduce complexity, try to reduce some sort of areas where things might conflict. And so you will start to see, like, there's a general term now, interconnection equipment, instead of saying transfer equipment or transfer switches, and there's a lot of these little things that have been baked in there that, it is definitely worth a sort of reread if you work in those areas, and don't just go into it saying like, well, it used to say this, and I don't see, I didn't hear that there was any change. I'm just going to assume it sort of says the same thing. But there's just been a lot of extra work done to try to get the language just a better fit with some of the systems that we build, and not just matching up with like the old, single generator transfer switch, blah, blah, blah.
Yeah, and I think that's, for me, having taken part of that whole process, I mean, it was an education aspect in the room in real time of, how these systems actually work, because there was people raising their hand like, what do you mean it shuts down and it doesn't, we're not coming back on or have that ability. I mean, 702, if we're going to use the always language, it's always around generators, right? I mean, generators were that source to do this. And so this is somewhat brave new world stuff for even some people on the code making panel, and they're learning as well. So I think it's just an interesting way, and because of the way our technology is and how we're now, adapting or moving on.
Yeah.
Okay.
Good progress.
Great progress. So real quick, just some key takeaways that we're getting really close to the top of the hour. And one thing James, I saw your question about the balcony solar. I didn't give Jason a chance to talk about that because this is going to go way too long.
Definitely another hour. Yeah.
Yeah, exactly. So definitely something that's being talked about within the industry. And so the answer is, yes, there's some stuff around there, but we're a ways away to go before we have any good comments. So, kind of leave it there. And so, yeah, more changes coming in 2029. It's a reorganization change. So just numbers are going to change, all that kind of stuff. Content will really it'll be there, but numbering systems. The disconnecting means was kind of one of the big takeaways I wanted to talk about. And then these PCS and EMS, these larger roles that they're going to be playing within our systems. So those are the big ones. Jason, I don't know if you had anything else. I'm going to flash seeing that we're right at the top of the hour, I'll give you an opportunity, but I want to give people our contact info if you have questions or comments. I think we got through most of the questions. So yeah, any last words that you want to put out there, Jason?
Yeah, I mean, no, thanks for this. This is definitely not everything.
Yes.
So this is just a taste of it. And there are interrelated articles, I think for ESS, I think 705 is one of the big ones.
Yes.
And yeah, and then the final thing is, yeah, there's going to be big changes next cycle. And we have an accelerated cycle. So the public inputs for the 2029 are due in April of next year. So better get your copy and start reading right away because you don't have
Yes,
much time.
exactly. Yeah. So that's a good point. People always ask about, getting involved. There are ways of getting involved, but public comments are shorter this year, or the shorter timeline. And so getting those in by April is an important thing. SIA is where I would probably direct people to in terms of the most effective way of getting involved for the solar industry and making those comments and those changes.
Yeah, that's
Okay.
right.
With that, I will say thank you to everybody for attending. Great questions, really appreciate it. And we will see you next month when we do our next AMA. So thanks a lot, Jason. Appreciate it. And
Yeah,
we'll see you all
thanks, Ryan.
later.
Good to catch up. See ya.